This is AP Calculus AB, Notes Section 7.5, Finding the Area Between Two Curves, and Application of Integration. This section is pretty cool. It's going to take a concept that you already understand well, give a little spin to it, a little derivative, as they say in the math world. And then when we get to the next section, which is even cooler, we're going to be able to just roast some marshmallows on those babies. I don't know what that means. It just came out. So in order to learn this new concept, let's first revisit an old concept. Graph the function of f of x and find the value of the integral from -5 to 0 of f of x, mad props to x. Using one color, shade the region for which the value represents the area. Well, let's first graph this little fella. We should know this is a quadratic. It's going to be a parabola. Since the lead coefficient's negative, it's going to open down. In order to know how to graph this, we need to find the vertex. The vertex can easily be found using the derivative. So this is the work for the graph. If we take the derivative, f prime, derivative of -1/2 x squared, you take the 2 times the front, 2 times -1/2 is -1. Subtract 1 from the exponent, and it's going to be x to the first. The derivative of a -2x is a -2. Derivative of a +4 is 0. The derivative represents the slopes of all the tangent lines, and we want a tangent line that is horizontal. It'll be horizontal at the maximum. For the tangent line to be horizontal, the slope has to be 0. So we set the slope, f prime, equal to 0, and we solve this little mother for x. We get x is -2. So we know the vertex is someplace at -2. Don't know how high or how low. So let's figure out what the y value is on this graph when the x value is -2. So we take the original function, replace x with -2. It's -1/2 times -2 squared, order of operations, u exponents first, minus 2 times -2 plus 4. I'm trying to be more dramatic in my videos. Can you feel the drama? Oh, this application has been messing up today. Picklesworth. I've already restarted this video once. I shan't do it again. I shan't. Hopefully I didn't lose what I had already written. I didn't. All right. So what I was trying to do was innocently just trying to make this a little bigger. Oh, wheels are falling off. Simplifying this, we're going to get -1/2, -2 squared is 4. A -2 times a -2 is a +4, and we had this other +4. -1/2 times 4 is -2. 4 and 4 is 8. That's going to give us 6. Here's what we know. We know that our vertex is at -2, 6, which is right here. We know that this opens down once again because lead coefficient's negative. How does this 1/2 affect the graph? That is a dilation vertically of 1/2. Here's what that means. Normally from the vertex, since we're going down, we would go right 1 and down 1. Since this is dilated by 1/2 vertically, we go right 1 and down 1/2. I'm going to put a dot here. Normally, we would go to the right 2. 2 squared is 4, and down 4. 1, 2, 3, 4. But since it's dilated by 1/2, we're going to go right 2 and down 2. Let's continue with this logic. 1, 2, 3 to the right, usually you go down 9, because 3 squared is 9. We're going to go down 1, 2, 3, 4 and 1/2, because that's half of 9. Repeat these dots on the left because there's some symmetry here involved in a parabola. I can go one more, I guess. If I go to the right, 1, 2, 3, 4. 4 squared 16. But since there's a half, I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, and 8. So our graph looks something like this. This is f of x. And graph the function, did it, find the value of the integral. Haven't done it. So we're going to integrate from -5 to 0, -1/2 x squared minus 2x plus 4 with respect to x. Integrating this, if we add 1 to the exponent here, we're going to get x cubed. Its reciprocal is 1/3 times the -1/2 that's already there is going to be -1/6 minus, add 1 to the exponent, it's a 2. 2 times, the reciprocal of 2 is 1/2 times the 2 that's already there. It's going to be a -1 x squared. And then the last one is going to be 4. Its antiderivative is 4x. We're evaluating this from -5 to 0. I've got 1, 2, 3, 4 more lines, so hopefully you're not writing too big. We are going to take and put 0 in for all the x's. And we're going to subtract from that, putting in -5 in for all the x's. Let me cheat, as I often do. Now this first set of brackets is a bunch of things that are being multiplied by 0, so it's just 0. The second set of brackets, a -5 cubed is a -125, and that's being multiplied by -1/6, so negative times a negative is a positive. Here, a -5 squared is positive 25, and we're subtracting that, so less 25. And then here, 4 times -5 is -20. If I distribute this minus, keep in mind a -25 and a -20 is a -45. If I distribute the minus, I get -125 over 6 plus 45. If I round to 3 decimal places using a calculator, this was a non-calculator problem, I'd leave it like that and do nothing else. But the calculator problem, I might throw it into my calculator and get 24.167. Let's see if we answered the first question. Graph the function of f of x. Did it. Find the value of integrating -5 to 0. Did it. Using one color, shade the region for which this value represents. Well, this value represents this red area. I'm going to change this color to green. So we've the graph, we found the value, we've shaded. There are 3 things to do. We did all 3. Next question. So everything we did in that first question we've done before lots of times. I know you know how to do that. It's good to review. Graph the function g of x, which is -1/2 x plus 4 in the same grid, and then it's asking us to find another value. So let's do that. Let's graph this on the same grid. It was positive 1/2 x plus 4. I'll use a different color for this. The y-intercept is 4. The slope is 1 over 2. So I go up 1 to the right 2, up 1 to the right 2, or down 1 to the left 2, down 1 to the left 2. Connect your points with a line. This is called function g of x. Dig it? Graph the function. Easy enough. Same grid, did it, and then find this value. We are integrating from -5 to 0, 1/2 x plus 4, mad props to x. Let's do that. So the antiderivative of 1/2 x, we add 1 to the exponent, multiply the reciprocal. The reciprocal of 2 is a half. A half times the half that's already there is a quarter. Plus, antiderivative of 4 is 4x. And we are integrating from, or we are evaluating from -5 to 0. So this first is going to be evaluated at 0. I always take more time when I rush. So why do I rush? I don't know. But it annoys me more than you could possibly imagine. My impatience causes me to be more patient. This first group is going to be 0 plus 0 is just 0. Second group, -5 squared is 25. 25 times a fourth will be 25 over 4. Second group, plus 4 times a -5 is a -20. I'm not going to get real crazy with that. I'm just going to leave it as -25 over 4 plus 20. If I were to put this into a calculator, I would get 13.75. Exactly, if I want to go 3 decimal places, throw a 0 on it. Using a different color, shade the region for which the value represents the area. So, let me try to use yellow. That's not yellow. This represents the area underneath the curve from -5 to 0. What does any of this have to do with something new, you might be asking? Well, let's go on to this next question. What do you suppose you would do to find the area of the region that is located between the graph of f of x and g of x? Here's what that means. If we were to take, let's say, I'm going to put a little handle on this so I can move it. If we were to take this pink area, which we actually don't want to know the area of, and we were to take, I got too much there. Oh, geez. And we were to take all the pink area that we have here, and we were to subtract from it the yellow area. Guess what we would end up getting? I think you know. We would end up getting this black area, which is really what we're after. Now, you've done this type of thing before. You've done it in geometry. Yes, you have. Don't argue with me. For example, let's say that you want to find the area of the shaded region, and the shaded region consists of all the area inside the circle except for that triangle. Well, to find that area of the shaded part, you would find the entire area, which is the entire circle, and subtract out the part that you don't want. Same concept here. If we want to find this green area, we find all the area under the curve, which is giving us too much, subtract the yellow part that we don't want, and then we would get this green area. So what does that mean for us using calculus? Well, the area between f of x and g of x from -5 to 0, that's going to be the area under the curve of f of x. Well, let me tell you how to write this formally. It's going to be integrating from -5 to 0. F of x was first, I'm sorry. F of x, and then subtracting from that, integrating from 5 to 0, g of x. And we found the area under the curve for f of x was about 24.167, and for g of x was 13.75. You subtract those, you get 10.417 square units. I am suggesting that this green area here, that is the area of that green area. Hopefully that makes sense. Let's do a real problem where we get rid of the baby steps, and it will be the same problem that we just did. I just took a nice swig of sugar Pepsi. Boy, that hit the spot. Now find the value of the definite integral below. And showing your work, it's a problem that we just did, but let me show you how compact this work can become. And at first glance, it's like, wow, this is twice the work as a regular problem. In most cases, it isn't. We are integrating from -5 to 0. Function f, which is -1/2 x squared minus 2x plus 4. Subtract function g, 1/2 x plus 4. Notice up here we wrote this as two integrals, which we still could do, or we could just put it using one integral, but the first function minus the second. The most important part, the most cautionary part of this, is the second function has got to be in a grouping symbol. The first one we typically put in a grouping symbol just to emphasize it's the first function, but it has no mathematical value. Now before we integrate this, let's combine like terms. Let's get rid of parentheses. Let's see if we can make this simpler. -1/2 x squared has no like term. Or minus 2x, we could write as a minus 4 over 2x. I'd want to do that, so I can combine that with its like term of minus 1/2 x. Minus 4 over 2x minus 1 over 2x. The x is not on the denominator. I made it sound like that. It's going to be a minus 5 over 2x. And then the plus 4 and the minus of plus 4, those cancel. We are just integrating here two terms, as opposed to 1, 2, 3, 4, 5, which is what we did using the other method. Boy, I am writing entirely too large. So, to integrate -1/2 x squared, add 1 to the exponent, multiply by the reciprocal. So a third times -1/2 is -1/6. Add 1 to the exponent, multiplied by the reciprocal, it's going to be -5/4. We're evaluating this from -5 to 0. When you evaluate it at 0, if you're not like super stoked about doing calculations by hand, that works out nicely because when you evaluate it at 0, you're going to get 0. When you evaluate it at -5, if you're not super stoked about calculations, sorry about your luck, kid. -5 cubed is a -125 times -1 is positive 125 over 6. Over yonder, I messed up. This is squared. I wrote to the fourth in both cases. Thousand pardons, thousand pardons. The big difference between those two things. Anyhow, a negative 5 squared is 25 times this subtract 5 is a subtract 125 over the denominator of 4. Simplifying by distributing the signs, the subtract sign, you're going to get negative 125 over 6 plus 125 over 4. They could get common denominators and put those together, blah, 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 blah. Or throw it in your calculator and get 10.417. Notice how that is the same answer that we got previously. Coincidence? I don't think so. What do you notice about this value? Well, it's the same value that we got before. That's what I notice. So this is the process that you use to find the area between two curves. Simple. Lovely. This brings us to the general way that we will find the area between two curves. So if you're going to write one thing down from this notes, if you're making a cheat sheet for your study guide for the end of course test, this is what you would write down. Area between f of x and g of x equals integrating from a to b f of x minus g of x. Mad props to x. Let's add a little bit more where a and b are points of, let me be more specific, where x equals a and x equals b are points of intersection of f and g. And where f of x is bigger than g of x. So what that last part means, I don't like how that's written, but that's how you should write it. F is the upper curve, and g is the lower curve. It's upper curve minus lower curve, because the upper curve is going to give you all the area between the curve and the x-axis, and then the lower curve gives you its part. If you subtract those, you find the area that you're trying to find. Example, find the area of the shaded region R that is bounded by y equals sine of pi x and y equals x cubed minus 4x. Which curve is which? Hopefully, you recognize sine as starting out at 0 and increasing at the beginning. I know this pi is going to change some things with the curve, but this one here is sine. Hopefully you also recognize what a cubic function looks like. And depending on, well, we can't see the whole function. That's a little bit harder to pick out with what you see here, but this is x cubed minus 4x. So the first things you want to pick out on this, where do these curves intersect? If it says find the area bounded by the curves, that means that these curves are creating boundaries, and where they intersect each other, which is right here, which is at x equals 2. Let me not say x equals 2. Let me say that b equals 2, which is still an x value. Here they intersect at 0, Let me say a equals 0. Then you want to figure out which one's the upper and which one's the lower. We already established that the sine was the upper and the other one was the lower. If you're unsure by looking at them, pick a number like 1, put 1 into each of these, and see which one gives you this value of 0. This one clearly will. So to find the area, we're going to integrate from 0 to 2. Once again, those are the points of intersection of these two curves, 0 and 2. We are going to take the upper curve, sine of pi times x, minus the lower curve, x cubed minus 4x. It's always upper minus lower. Always. Now we can get rid of some signs here. Like we could write this as, I'll tell you what, I'll do this one a little bit different than I did the last one, just to show you that it can be done differently. If that matters to you, may not. We could write this as two separate integrals. Why would you want to do that? I don't know. You could. Maybe you don't want to. It don't matter. Integrating this first one, integrating that directly is going to be difficult. Let's set u equal to sine of 4x, which makes du over dx. Got to use a chain rule here. Derivative of sine is cosine. Inside stays the same. Times the derivative of the inside, that would be 4. You know what? I don't want to do that. That's a terrible idea. That's horrible. Let's set u equal to 4x. That's what I want to do. That's going to make du over dx equal to 4, which makes du 4dx, which makes dx 1/4 du. That's what I want to do. So when I'm integrating here, I'm going to change this 4x to u, and dx becomes du. Now you got to be super careful here because the upper and lower limits now change because I've made this. You know what? I didn't do that well. I'm just getting so excited, ahead of myself. I'm replacing 4x with u. I'm replacing dx with 1/4 du. Now at this point, this 1/4 we can take to the front, and the upper and lower limits are now changed. If I put, oh dear, what's happening? This is a pi. I wrote a 4. Well, on a positive note, this virus has not affected my mind because I was doing this kind of stuff pre-virus. How about that? Let me highlight the stuffs that I just screwed up. This, and this, and this, and this, and this, and this. It's not 1/4, it's 1/pi. Oh boy. If you put 2 in here for x, that's going to make the u equal to 2 pi. So the upper bound is 2 pi. If you put 0 in here for x, it's going to be u equals pi times 0, which is still 0. And then we can pull the 1/pi to the front, and we can just integrate sine of u with respect to u. I'll come back and pick up this fella here in a moment. I'm just going to continue with this. It's going to be 1/pi. If we integrate sine of u, that's going to be negative cosine of u. I'm going to put the negative out here. We're integrating from 0 to 2 pi, or we're evaluating. We already integrated. Can't pinch and zoom. There we go. So we're going to have negative 1 over pi. Just going to leave that out in front. Going to have cosine of 2 pi minus cosine of 0. Once again, I haven't forgot about this. I'm just going to come back to it. Cosine of 2 pi is on the positive x-axis. Cosine of that is 1. Cosine of 0, that's on the positive x-axis. Cosine of that is also 1. So this whole thing ends up being 0. Well, that's convenient. Now we could have conjectured that at the beginning, because this area here is identical to this area. One's positive and one's negative. Now let's focus on this other curve. If we integrate x cubed, we add 1 to the exponent, multiply by the reciprocal, we're going to get 1/4 x to the 4th. If we integrate negative 4x, we're going to get negative 2x squared. This is evaluated from 0 to 2. Then, I've got to continue with lots and lots of brackets here. They're going to have brackets inside brackets. Going to have 1/4 times 2 to the 4th minus 2 times 2 squared. This other one's going to end up being 0 because we got 1/4 0 to the 4th minus 2 times 0 squared. So this first one, 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 1/4 of 16. And over here, 2 squared is 4, times another 2 is 8. We're subtracting 8 from this. This whole thing over here is 0. So 1/4 of 16 is 4. We got 4 minus 8. 4 minus 8 is negative 4. Subtracting a negative 4 is like adding a 4. So we end up with positive 4. I think it's super cool. It's going to be square units. That the area between these two curves, oh, my tools stopped working again. I got to exit out of this and bring it up again. Ain't that sad? Hope I don't lose that again. Didn't lose it. I think it's super awesome that all of this curvature is happening, and the area between these two curves is exactly 4. That is nuts! You can't sit there and tell me that's not. It's pretty nuts. Well, let's do this now. We did it by hand. 2 different problems by hand. Let's use our calculator. Pictured to the right below is the graph of f of x, and it is a doozy. And line L, which is tangent to f of x at point 0, 3. That's important to know. Find the area of region R. Now, there's some things you're going to want to have to do here before you even attempt to find these areas. You definitely want to know for sure, what is this point of intersection here, the x-intercept? Obviously, this one here is 0. We want to find this point of intersection between L and S, which at this point, there's really no way of finding this. We can find this one, though. So what you do, you go into y1, and you type in this function. Hopefully, you don't have any problem doing that. And then once you graph it, You hit second, calculate, choose 0, and then it says left bound. Make sure your cursor's someplace on the left, and it says right bound. Make sure it's someplace on the right. Probably have these kind of marks. Have it guess. I got this point of intersection here, the x-intercept, to be negative 1.373. We have to know that. The reason we can't find this one right now is we have no idea what the equation of L is. No idea. Find the area of region R. Before you write this down, pause the video, please, and see if you can make the equation to find the area of region R. All right, welcome back. That was a great pausing session. The area of R going to be integrating from the x value of negative 1.373 to the x value of 0. And which function is this? It is function f. Just going to emphasize this is function f. This is function f. Now to find this area, we're going to ask our calculator to do it. So once you've got this in y1 and you're looking at your graph, hit second, calculate. And then I think it's option 7. I don't have my calculator on my person, the one that looks like an integral sign. And then lower bounds, negative 1.373, upper bound is 0. And then it's going to give you, I think, 2.903 square units. Good enough. Find the equation of line L. Oh, interesting. If line L, if it is tangent to the graph of f of x at 0, 3. Well, to find the equation, we have to have a point of tangency, which we already given, 0, 3. We have to have a slope of tangency, which we do not have. Since we're using our calculator, we can just find the derivative of f and evaluate it at 0. If you do that, let me just grab my calculator just to remind myself of how you punch that in. Yeah, so once you have this function graphed into y1, this function meaning this one here, you hit second, calculate, and then you choose option 6, dy over dx, and then choose the value of 0, and it should give you that slope is negative 1/2. You know, it might give you negative 0.49 repeating, might give you negative 0.500001. It's negative 1/2. Once you have a point of tangency and a slope of tangency, then we're going to use point slope form. That's y minus 3 equals the slope times the difference of x and 0. We usually leave it in this form. We're going to be using this to find other stuff, so we would want to get y by itself. If I distribute the negative 1/2, and then if I add 3, we're going to get that y equals negative 1/2 x plus 3. We were supposed to find the equation of line L, so this here is line L. I'm going to add that to my picture. This is y equals negative 1/2 x plus 3. Next question. At what ordered pair other than 0, 3 does the graph of line L intersect the graph of f of x? Well, I would simply put into y2 this line we just found. So I got in y1 f of x and y2 L. I would ask the calculator to find the intersection by doing second, calculate, intersect, and then it asks you for the first curve, second curve, and then it wants you to guess, it's going to guess the answer. I got 3.39, comma 1.305. Hopefully you got the same. Make sure you're doing this along with me with your calculator. Find the area of region S. Well, let's look and see what that is. Also, let me also add to this picture, which is super important. This point of intersection has an x value, we said, of 3.39. If we're going to find the area of region S, we have to know what the upper curve is. The upper curve is L. We have to know what the lower curve is. The lower curve would be f of x. And you have to know the bounds that we're doing this by. We're going from 0 to 3.39. So when we write this, we can simply do this. Area of S is going to equal 0 to 3.39 of L minus f of x with respect to x. Now, how would I do this in my calculator? I would go into y3 and I would type in y2 minus y1. Because we had L in y2, we had f in y1, and then from there, and this is not part of your work, I'm just explaining it. Once you have that, I would do, you graph it and hit second, calculate, and then you're going to choose option 7, which is integrating. And then the lower bound is 0, and the upper bound is 3.39. You should get this is about 6.982. You don't have to put square units on these things, even though there is an area, unless the directions specifically say, put the proper units. Please do me and you a favor. Please stop this video right now. Please do this last problem using your calculator. I will throw the answers up here, and then you can continue. So pause and pause it when you've used your calculator. And we're back. Pictured our regions R and S. We got function f and function g. This is function f. This is function g. How do I know that? Well, this is an exponential function. And since this is negative, it opens down. There's only one curve to it. This is a trig function, which is continually going up and down, which I guess we can't technically tell it's coming back, but this is 1/4 bumps it up. So instead of 0, 0, it's going to be here at a fourth. Identify the points of intersection of f and g. Well, I found this point of intersection here to be 0.178. It's the x value. And this one here to be at 1. So I got 0.178 followed by a y value of 0.781. That doesn't sounds too coincidental, but that's what I had on my paper. Hopefully that's great. And this other one was 1 1/4. Find the area of region R. Which one's the upper curve for this one? G is. So G's got to be first, followed by the lower curve, which is F. The lower limit is 0. The upper limit is 0.178. This is a super zoomed in picture of this graph, by the way. And that's obvious when you find this area of 0.065. Find the area of region S. Well, for region S, which is the upper curve? That's f of x, and g of x is the lower curve. And we're going from 0.178 to 1. I'm just going to write this down here, then transfer it. Area of S, lower bound is 0.178, upper bound is 1. We got function f minus function g. F is higher, g is lower. And I found this to be about 0.410, all with my calculator. Last one, find the area of the unshaded region bounded by the curves. Well, this is interesting. I'll do this to the side again, then write her down below. We have to do this 3 different ways. We're going from 0 to, okay, it says bounded by the curves in the x-axis. So to be clear, it's wanting us to find this area. I'll explain why in a minute. I'm using different colors. And this area. And then this area. The reason I have three different shades there is because in this region, the lower curve is F. In this region, the lower curve is G. And in this region, the lower curve is F. We're trying to find the area between the lowest curve and the x-axis in each case. Or to do this last part, I got to figure out where function f touches the x-axis. And I found that to be 1.080. So to find the unshaded area, got 3 of these once again. We're going to go from 0 to 0.178, and that's going to be function f. And we got to add to that from 0.178 to 1, that's function g. And then we got to add to that from 1 to 1.080, and that's function f again. So I found this to be 0.093 plus 0.383 plus 0. These all should probably have zeros in the front. 0.010. So this right here we're saying is 0.093. This is 0.383 and this is 0.010. Put those together, you're going to get 0.486. Using your calculator, you have to do each of these separately. Find this one, write her down. Find this one, write her down. Find this one, write her down. A little tedious. Nothing you can't handle. There is a special homework assignment for this. Click on the link on the website for the remote learning. It's a video assignment, and it's going to take you a little while to do it. It's going to be a little tough. And the most important thing is for you to stick with it. No smiling while you're doing it. Math is supposed to be a miserable experience. Thank you for paying attention. Enjoy your quarantine.